Hey guys, welcome back. Today is not new information. This is an assignment you're supposed to be doing just to keep yourself fresh. So this is all review, and it's going to be a real quick lesson just if you've forgotten all the things about motion problems, okay? So first, a couple of things you need to know. Position, velocity, acceleration. Hopefully this is second nature to you by now, and these are all things that are on your justification sheet that I also posted for you in Canvas. So position does not have a standard notation. Position can be S of t, it can be P of t, it can be X of t if it's motion on a x-axis, it can be Y of t if it's motion along the y-axis. So position does not have a standard notation, but velocity and acceleration do. Velocity is the first derivative, acceleration is the second derivative, and hopefully you know that speed is the absolute value of velocity. Okay, this is where you really get into the nitty-gritty though. Notice that all of these justifications involve velocity. This has to be memorized, and there are a lot of questions on the AP exam about this. Anytime they ask you, is the particle or the turtle or the whatever moving left or right, you should immediately write on your paper, velocity negative, velocity positive. Any of these things that have positives and negatives in them mean you need a sign chart to do them, okay? Memorize this, please, 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 okay? Now, speeding up and slowing down, that one I usually have to hit hard right before the AP exam. If I give you the picture, then speeding up and slowing down is pretty straightforward. But if I give you the equation, you got to use this, okay? Let me show you what I'm talking about for speeding up and slowing down. So if this is the velocity graph and speed is the absolute value of velocity, okay? When velocity is negative, all of this is particle or turtle or whatever it is, this is particle. All of this is particle moving to the left. So this is going left because velocity is negative. All of this is moving right because velocity is positive. Velocity is 0 here, here, and here. That's particle is stopped. Particle turns around when velocity changes sign. That would be here. Okay, now let's talk about speed. If speed is the absolute value of velocity, then the velocity right here is -2, but the speed is 2. So in this first section from here to here, you're going from a speed of 0 to a speed of 2, so that's speeding up. This is a constant speed. This is slowing down because you're going from a speed of 2 to 0. So speeding up, constant, slowing down. In the next section, we're going from a speed of 0 to a speed of 4, so that's speeding up, constant, slowing down. So to summarize, if you're going away from 0, you can think of this as speeding up, speeding up. If you're going towards 0, slowing down. Okay, well, that's great, but when I give you the equation instead of the graph, it gets a little bit more complicated. So let's look at speeding up and slowing down again, another way. Speeding up is supposed to be when velocity and acceleration have the same sign. Okay? Well, we already said speeding up was this section and this section. Well, let's look at it from this definition. Let's write down the sign of the velocity. Well, all of this is below 0, so all of that is velocity is negative. Negative, negative, negative. Okay? All of this is velocity positive. Positive, positive, positive. So that's the sign of the velocity. Now let's do the sign of acceleration. Acceleration is the derivative of that. So where will I see that on the graph? The derivative on the graph is the slope. So my slope here is negative, so my acceleration is negative there. The slope here is positive. The slope here is positive, and the slope here is negative. Okay? So, where do velocity and acceleration have the same sign? Right here, speeding up, and right here, speeding up. Okay? Where do they have opposite signs? That would be slowing down, right here and right here. This is slowing down. So graphically, speeding up is going away from 0. But if I give you the equation, you got to know these formulas. Speeding up is velocity, acceleration have same sign. Slowing down, velocity and acceleration have opposite signs. Think of this as going backwards, but going backwards faster. All right, so let me do an example like that. this is similar to the last problem on your worksheet for today, okay? They're asking, where is the particle slowing down and speeding up? So we need to find velocity and acceleration, and this is the position equation that's given. So we're going to find velocity and acceleration, okay? And we're looking for their signs. So we're going to do a velocity sign chart and an acceleration sign chart. Okay, speeding up will be where the signs are the same, slowing down will be where they're different. So velocity, first derivative, negative 3t squared plus 40t minus 100. Acceleration is the derivative of that, negative 6t plus 40. Okay, now we need to do two sign charts, okay? So this first one, for velocity, we're going to set that equal to 0. When it's a negative out front, don't divide by it. It'll mess up your signs on your sign chart. Just factor it out. Leave it there, though. Okay, leave that negative there. Factor. I had to make a little bit of room. Okay, so now I'm factoring. So to get 100, I'm going to try 10 times 10. Let me see if that works. My inners are 10, my outers are 30. I can make them both negative. Yep, that works. Okay, then set each factor equal to 0. This one would give me t equals 10/3. This one would give me t equals 10. And remember, you can't have negative time. So now I'm going to focus on my velocity sign chart. 10/3 is 3 1/3, so we have a 10/3 and we have a 10. Okay, now when you plug in, when you're checking the sign of your velocity here, make sure you incorporate this negative. Okay, we're plugging in right here. If I plug in a number to the right of 10, like an 11, this would be positive, this would be positive, but there's a negative in front, which makes this negative. If I plug in a number to the left of 10/3, like 0, this would be negative, this would be negative, but there's another negative here. 3 negatives would give me a negative. If I plug in a number between 10/3 and 10, you end up with a positive. Okay, now I'm going to bring acceleration back into this. Okay, set this equal to 0. Solve for t. Divide by negative 6, and t is going to be 20/3. Okay, now we know we're going to do an acceleration sign chart. Checking around 20/3, okay? Plugging it in here or factored form. To the left of 20/3 would be 0. If I plug in 0, I get a positive. To the right of 20/3, pick any number you want. That one's going to be negative. Okay, now we have to interpret these two sign charts to come up with speeding up or slowing down. Speeding up is going to be where velocity and acceleration have the same sign. So where are they both positive and both negative? Both positive would be in here and here. So that would be from 10/3 to 20/3. And both negative would be after 10 here. They're both negative. So 10 to infinity. Okay. Slowing down is where they have opposite signs. So that would be negative here and positive here. Okay, so you might think negative infinity up to 10/3, they have opposite signs, but remember, time can't be negative. So we're going to go from 0 to 10/3. Okay, where else do they have opposite signs? In this region right here. So from 20/3 to 10. Okay, so that was a quick review. Remember, this is where you kind of just have to merge the two sign charts into one. All right, hope that helps. Good luck, guys.